I'm
Mm-hmm.
started recording. Okay, so now if we so there is something called a scope of a variable. The variable scope. Okay, what does scope mean is it is the English meaning. What a scope means is scope is until when is it applicable? When is it applicable? Okay,
Mm-hmm.
so basically what happens is uh, if you write a variable inside my file, okay, it is
Mm-hmm.
called as uh, your scope is within this file. Scope is within this file. So, for example, I
Mm-hmm.
say variable name, for example, Praveen, my name. Okay, Praveen is equals to 25, let's say. Then in anywhere else in this code, I can use this variable and it will refer to this 25.
Mm-hmm.
Okay, this is called as scope of a variable being uh, this thing. But let me show you an example now. Okay, so for example, here I am defining Praveen is equals to 25, for example. Okay. Now what I'll say is
Mm-hmm.
def something here. Okay, some function name I have given. No arguments. Okay. And let me
Mm-hmm.
just make this Python and this Python. Okay. So no arguments, and I'll say Praveen is equals to T. Okay. Print Praveen. Okay. And if I come out and say print Praveen. Okay. What will happen here is okay, I forgot to add it. So something here from this. Okay, so what is happening here is
Mm-hmm.
okay, let me add some text. This print is from within the loop, within the function. Okay, is from outside the function.
Mm-hmm.
Okay, so if you see what is happening here,
Yeah.
okay, though it runs this, then it changes this value, but once it runs it here again, it takes the original value. Why? Because it has this Praveen here. So let us take this example for now. Okay. So if let me just take a
If we
screenshot
call
of it.
only for the definition part, it will take this thing, you mean, right?
No, I mean, let me tell you. So the scope of variable is changing within here. So what happens is, um, okay, let me bring this here. So here, r- right now, there is something called as, let's say this is my memory. Okay. Okay. When I run this line, what happens is it will say Praveen is equals to 25 and scope is within this file. Okay.
Mm-hmm.
And
Mm-hmm.
then what I'm doing is I'm running this definition. Okay. But I'm not calling it right now. So it just looks at this. When you run these three lines without calling it, what it'll do is it'll look at this and say, is there anything wrong with this? Okay. So what it does is it'll compile this. Basically, compile means what it'll do is it'll convert it into a box where whatever how many arguments
Mm-hmm.
here, that many inputs it'll take, and whatever return you say, that many outputs it'll give.
Mm-hmm.
Okay. And action like print or something, do something, open a file, close a file, those kinds of things are called as actions where it will perform something. Okay.
Mm-hmm.
Okay. So what happens here is you might get confused right now. Just bear with me. Okay.
Mm-hmm.
So what it will do is um, here what it will do is it will say print. Okay. Now here you have called that function. When you have called that function, it will actually run this lines. So what it will do is it will generally create another variable called Praveen. Okay, is equals to 30, and it will keep its scope within the function. Okay, so
Mm-hmm.
any variables that you define within a function are scoped within that function. It's called as the scope is this block of information. That's all. The scope is within the function. What it means is
Mhm.
this value is valid when you run it within the function. So when I run this sentence, it will be able to say 30 here. That is what you saw in the output.
Mhm.
But once I come outside the function, since there is a conflict here, okay, so what will happen is once I'm running from here, it will not take this one because this is valid only within the function. Outside the function, this is not valid.
Mhm.
Okay, so it will take this value. That is why what happens is even if you run here, though the before it ran 25, here it will run 20, 30. Before it ran 30, here it will run 25 because the scope
Mhm.
of this variable. So here it prefers to take this variable than this variable.
Mhm.
Okay, so basically you can assume at this level, at the file level, it is this one that it is considering. Okay,
Mhm.
so is there a way can I make this variable the only thing that changes? So instead of here printing 25, here also it should print 30. Is there a way I can do it? Okay, there is a way. There is
Mhm.
something called as global. It's a keyword called global. So same code
Mhm.
as in VS Code. Okay, only change I'll do is, okay, instead of writing Praveen 25, I'll do one small addition. I'll say global Praveen. Okay,
Mhm.
uh, so there's no need to write like this also. Global.
Mhm.
How do I do this? I forgot. Okay. Let me just check once. How do I? Okay, this value 30 comes outside the function even though it is only defined inside the function because you're returning it outside. You're sending it outside the function. This is what sending something
Mhm.
outside means. So what you do is return tries to help you send something from within the box to outside. So you remember I defined a function as like a black box of something. It can have 10 lines, it can have 100 lines, or it can have 10,000 lines of code. Okay, it'll take some inputs. Okay, and it'll do some actions. Okay, it can do some actions which is generally seen, but it is not stored in memory. Okay, then it can give some
Mhm.
output. To give this output outside the function, to send something outside the function, you need to use return. Return is a statement that will send everything outside. Okay, inputs are
Mhm.
the arguments that you see. Okay, so
Okay.
when you define a function, you will say how many arguments that function should take. So for example, as we see here, I'm saying no argument. So it's not taking anything inside. Just when I'm calling this, it's not taking any input but giving an output. So if I have to draw a box for that function here, okay, so it will be this
Mhm.
is the function something here name, okay, and there's no input, there's only one output, okay.
Mhm.
So imagine if I just go back to my VS Code and let's say instead of just returning, I do some print, okay, print Praveen, let's say. So here I'm doing an action as well. This is an action because it is writing to screen. So it's writing here. That is where this is an action. But it is not stored in memory. To store it in memory, you have to return it outside the function.
Mhm.
So now I hope you understand what return does, what is scope, and generally
Yeah.
scope, how is it set. So sometimes what will happen is if you are getting confused, like if you for example use the same name inside and outside, it will become kind of confusing what is the value that is taking. So it's generally preferred not to do that, but once you get a hang of it, you can do it as well because you will know exactly
Mhm.
where the scope is. You don't need to search and understand and break your head on it. Okay,
Mhm.
so
Mhm.
now that we have talked about scope and everything, there is a very important concept called um I forgot what it's called. It's called um So there is an important concept called pass by reference and pass by value. Okay. This is again theory
Mhm.
for some time. Okay. So you have to understand this theory before we get on to the topic for today. That will kind of help you out to understand the theory, what is happening. Okay. There is
Mhm.
a concept called as, let me just write it down, pass by reference and pass by value. Okay. So what it is,
Mhm.
so for example, in a very simple layman's terms, I'll explain this. Okay.
Mhm.
So you have to send, okay, you have to send information to your friend. Okay.
Mhm.
This is your friend. Okay. You have to give him some information. What you can do is you
Mhm.
can, let's say the information you have to give is, let's say the number 30. You can say here the number is 30. So you are telling exactly the number directly to him. So that is pass by value. You will give the information directly to him. Okay. Pass by
Mhm.
references, you will put a envelope. Inside that envelope, you put 30 and you'll send it to him.
Mhm.
Okay. So you are sending the envelope. You are not sending the value itself. So instead of 30, it could be
Mhm.
anything here and you can put it here. Okay. Send by reference. Let me explain a bit more clearly in terms of computers. Okay.
Mhm.
Okay. So let's say now you have understood scope and everything, right? So you're sending values inside a
Mhm.
function, outside a function, and all those things, right? So let's
Mhm.
say you have to send some value to a function. Okay. Now let me draw a small box. This is a function. Okay.
Mhm.
This takes some input. Let's say only one input. Okay. And this gives
Mhm.
some output. Okay. So for
Mhm.
example, I'll say it'll take an input, it'll square that value and it'll give an output.
Mhm.
Okay. So imagine one way of doing it is directly giving the value as input here and saying, for example, take the number 2 as input. Okay. Then what it'll do is 2 square and give you 4 as output here. So here the pass is done by value.
Mhm.
Okay. But there's another way. So what will happen is when I say, for example, Kavin is equals to 2 or some, okay, instead of my name, let's say variable 1 is equals to 2 is what I'm storing the value as. So what happens is
Mhm.
variable 1, what it does is it will take first, okay, so what happens in backend is it will take the name. First, it will look at this value. Okay, what is it? Is it an integer
Mhm.
or float or string or what it
String.
is? No, it is a integer because I'm not giving
Integer, yeah.
quotations. If I give quotations, it will become
Mm.
string.
Yeah.
Okay, it's an
String.
integer. So let's say in Python for integer, the amount of space they will give is 8 bytes, 8 bits, or let's say 1 byte space. It is not 1 byte, but let's assume it is 1 byte. Okay.
Mhm.
So inside your RAM, now let's say your RAM is what? Let's say 100 MB RAM. Okay, so it means
Mhm.
100 megabytes, a million, 100 into megabytes, right? So 100 into 1024 into 1024 bytes, correct?
Mhm.
So imagine all this, imagine you have each byte as one pocket,
Mhm.
okay? Each byte as one pocket here. So, so you have 100 into 1024 into 1024 pockets in your RAM, okay?
Mhm.
So let's not take such big numbers for now. Let's take you have RAM wherein you have, let's say, 10 bytes you can store in your RAM. Only 10 bytes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, these are 10 bytes. So the address of
Mhm.
this byte, let's say, is A, B, C, D, E, F, G, H, I, J. Okay. So what you will do is
Mhm.
when you take this variable 2, it is an integer, so it will take 1 byte. And basically it will say, okay, take a variable, uh, first empty place that it finds or random empty place that it finds, it will store the value here of 2 in binary. Okay.
Mm-hmm.
So for 2, the binary value is 0, 0, 0, 0, 1, 0, if I'm not wrong. 0, 1, 1, 0. Yes, this is the, so it'll, so 2 in binary, if you write, it is 0, 0, 0, 0, 0, 0, 1, 0. Okay.
Mm-hmm.
So this is the value. It will store all the zeros here. 0, 0, 0, 0. So it, so every byte will have 8 places where it can either store a 0 or 1. Okay. So basically you're storing your 2 in binary here. That is what you have to remember.
Mm-hmm.
Okay. Now, uh, pass by value, what it means is, when let's say you are giving this 2 to this function, what are you doing? You are saying, take this 2, copy it outside, and then send it here. So the value you are sending it here.
Mm-hmm.
Okay. This is pass by value. In pass by reference, what do you do is, instead of sending that 2, what you will say is, there is a value at location A. Take this A, and whatever the value is inside it, use that value and give an output here.
Mm-hmm.
Okay. So here what, as I said, you are taking the envelope here. Instead of taking the value directly, you are taking the envelope. You are taking the address
Mm-hmm.
of where it is stored and you are passing that. So this is called as pass by reference.
Mm-hmm.
Okay, where you are sending where it is stored that to inside, but you are not sending the value directly. Effectively, in this case, what will happen is, you will say at A 2 is stored, and then you will come out and say, okay, you'll multiply it by 2 and it will become 4. So both of them will give you the same output 4, but the way you are passing the information to that function is different. And this we will see practically how it happens in lists. Okay.
Mm-hmm.
So So you're clear on pass by value and pass by reference.
Yeah.
So instead of passing the actual value, so you take this value out and give that input here. You will take the address of it and give it input here. This will pull the value
Mm-hmm.
from this side and then work on it. Do whatever
Mm-hmm.
the suppose it is supposed to do. Okay. So hope you are clear on this pass by value and pass by
Yes.
reference.
Yeah.
Okay. Now let's look at lists today. Most of this will be applicable to strings, not all of it. Okay. So
Mm-hmm.
in lists, we will do something called as list. Uh, we'll work on list basically. Okay. So actually, before I go to that, in Python, lists, how are they stored in memory? Okay. So what happens
Mm-hmm.
is, there are different ways of storing lists in memory. Okay. Based on the different types of ways, they have different names. Okay. So a general
Mm-hmm.
list, for example, in list is not there. It is called as an array. Okay. What you do is, you will say, my in C language, you will say, I'll have an array. Okay. Of integers. Okay.
Mm-hmm.
And also what you will say is, let's say I'll have a length of 20. So what you can do is, what it will happen in backend is, it will take the memory RAM, and then it will say, I know integers are having, let's say, 2 bytes of memory for every integer. Okay. So what it will do is, it will say, for every number I'll have 2 bytes. So I'll take like this, all uh, 20 into 2. So I'll take 40 memory spaces in line. So it will start from
Mm-hmm.
example. So if you look at it, if you look at the memory address 0000A, then 000B, it will be in hex encoding. Okay.
Mm-hmm.
So it will take all those memory addresses in order. It will take. Okay. So what happens is, if you say, for example, the first value in my array is 2, the second value is 4, the third value is 6. What it will do is, it will just store 2 here, because it will take 2 bytes. It will store 2 here. It will store 6 here. Sorry, 4 here. Let me write it in a different color just so that you. It will store 2 here. It will store 4 here. It will store 6 here. It will store 8 here, and so on and so forth. Okay.
Mhm.
So if you want to get second element, so what you will do is inside your memory, you will store this first element's address of first element you will store. Okay.
Mhm.
And what you will do is you will say, now get me the second value. Let's say you want the second value. You remember I told you indexing. If you want the
Yeah, indexing.
second index, what is the value? Second value, what you will do is you will take the first
One.
address, whatever the address is, then you will add, second will start from after 2 bytes. So you'll add 2 bytes to it. So basically A, B, then it will be C. So you'll look at C and get the value that is there. Okay. This is how arrays do it. Okay, this is
Mhm.
one way of storing. But the limitations of this is you have to tell beforehand what exactly information you are storing, how much length you want to store in memory, and all that you have to give beforehand. So it will reserve that space for you, like in order. Okay, it will reserve like this in memory for you. If you
Mhm.
tell, this is a C implementation of array. But in Python, what they
Mhm.
did is they don't want your lists to be static like that. They want it to be dynamic, A, and B, they want it to have anything in it. So it can have, first one can be number, the second one can be string. So this will be string, it will be covering 2 bytes. Then next one will be a list, it will be covering some, let's say 10 bytes. Like that, it could be anything.
Mhm.
So the way
Mhm.
that is implemented in memory is what it will do is, okay. So now
Mhm.
imagine I have a list of numbers, let's say 2, then I have ABC, okay. Then let's say I have another list of 2, comma 4, comma 6. Just example, okay. And
Mhm.
assume this one takes 1 byte, this one takes 2 bytes, and this one takes, let's say, 10 bytes. Again, this is an assumption.
Mhm.
Just assume. So what? How
Mhm.
Python implements lists is first it will take the first element, okay. So this is your memory in RAM. Okay.
Mhm.
It will find where is the memory empty. Okay. The first element that it could find, it will take that. And it will say 2 is stored here. The address of it is, let's say,
Mhm.
A, B, C, D, so on, so on, so on, so on until A, B, A, C, like that. Big addresses will come. Okay.
Mhm.
So imagine then it will say, so whatever your first element is, I've stored it in C. Okay. Then second
Mhm.
element, what is it? ABC. Okay, it needs two
Mhm.
bytes. Okay, you'll say C for 1 byte of information. Okay, then what you'll do is second element is 2 bytes. So again, wherever it is empty, it need not be after it or before it. Wherever it is empty, it will take that place and it will store that information. Then it will say, I have
Mhm.
stored this in two places A and B. Okay, then
Mhm.
what it will say is, this one 246, it will store again somewhere. It need not be in order or anything. Okay,
Mhm.
and it will say, okay, 10 bytes of information. So it will take information of 10 bytes and it will store somewhere. Okay, it will store all the addresses in place so that it will be
Mhm.
able to pull information as necessary. So because of this, the advantage that you get is your
Mhm.
list need not have only one data type of elements in it. You can extend this list dynamically. So tomorrow, let's say you want to add one more element here. Let's say I want to add 10 here. Okay, a new, I want to delete this here. Instead of 3 elements, I want to add one more element. Okay, 10. And then
Mhm.
here. So what I just have to do is I'll have to take somewhere, I'll put 10, take that address and store it here. That's all. So I've
Mhm.
dynamically added an element which you are not able to do in C programming language.
Mhm.
Okay. But the issue
Mhm.
here is after this, what should come, how you will get. After this should come, how you will get. So actually,
Mhm.
what happens is what I've told you is a watered down version of what happens. Okay. It's kind of there's a concept called as linked lists. Okay. What linked list looks like very simply is in memory, instead of having 1 byte of information, you'll have three different sets of information. So, for example, if you have to
Mhm.
store two, okay, two in 1 byte, okay, then the head of it will
Mhm.
say none, it will say nothing here, or it will point to, let's say, for example, the list variable name. where is equals to this one. Okay, this is what you will point out to the variable name. Okay, then what you will say is
Mm-hmm.
uh, here also it will be null. Okay, none or null or whatever you will call it. Okay, then when you want to add the second element, you will again take another memory space. Okay, here you will store ABC, and here it is 2 bytes long. Okay, and what you will say is here in its head you will add the memory address of this. You will add here. Okay, so for example, the memory address of this is A, the memory address of this is PQR. Let's say, take an example. Okay, so here you will add the
Mm-hmm.
address A, and here it was none earlier, right? You will delete this none. Okay, and you will add PQR here. Okay, then for example, you want to add a new element again now. For example, you want to add the 246. Okay, now this is of length 10 bytes. Okay, here what you will do is head will be this one. So here you will have PQR, and the, for example, the address of this, let's say it is AAC. Okay, so here you will
Mm-hmm.
add AAC. Okay, so what will happen is once you start running through this list, you will first go to first element. Okay, I got the value here, so the value is 2. Okay, next I have to go to PQR address. I'll go to PQR address. Okay, the value is ABC. Okay, now next element is at AAC, so I'll go to AAC. Okay, at AAC the value is 2 comma 4 comma 10. Okay, okay,
Mm-hmm.
now I don't have anything to go to, so my list is complete. So you are able to store in memory separately, and using this linked list concept, you are able to jump around and get whatever information you want in the format that you stored it in. But in memory, it is
Mm-hmm.
stored somewhat differently.
Okay.
You understood this concept?
Yeah.
If you want to learn more about this, open any data structures and algorithm design book. You will have full theory on this. Or search for linked lists, queues, stacks, and you will have enough information about this, how they are implemented and all that. Okay, I am trying
Mm-hmm.
to give you a version that it is easy to remember. It might not be
Mm-hmm.
100% how it is implemented in memory. Okay, almost
Mm-hmm.
there, but I don't want to complicate with more of the mundane stuff, which we'll never think of also. So I'm not touching those things. I don't want you to do a theory course in this. I want you to do a practical course in Python. That is where I'm not touching it. Only things that you need to understand are the things that I am showing you.
Mm-hmm.
Okay. So now let's go to VS Code, and let me go here, and now let's start working on lists. Okay. So for lists, what can you do? Lists, but this is applicable to tuples and okay, limited applicability to tuples and strings. Okay. So where it is applicable, where it is not applicable, I'll keep telling you once we get to that point. Okay. So
Mm-hmm.
what is the main
What
difference
about
between list and
range? I think
tuples?
there's range also, right? In this?
Range is a function.
Okay.
Okay. So for example,
Mm-hmm.
I'll come to range in sometime. I'll come to range. Okay.
Mm-hmm.
So now let's start our first thing. For lists, what you need to do is, for example, I'll create a simple list called, okay, let me just copy this from an example in internet. Okay. There's a simple list of variable name my list, which is the values apple, banana, and cherry. Okay.
Mm-hmm.
If I want to pull banana, what should I do? This I've already explained.
Mileage 01.
You have to
1.
open bracket, square bracket, and say
Mm-hmm.
1. So it will say pull the first element, uh, pull the element 1 out of this list. So numbering always
Yeah.
starts at 0. So this is 0, this is 1, this
Yeah.
is 2. So it will pull this element and say this is 1. Okay. The
Mm-hmm.
first element of the list
Mm-hmm.
is 1. So always remember in a list or tuple or string also, the numbering will always start at, okay.
0.
So
Mm-hmm.
let's take a list. Okay. So let's say apple. let's say banana.
Mm-hmm.
Okay, let's say orange. Let me bring one more thing. Let's say football. Okay.
Mm-hmm.
Okay. So if I count from left to right, the numbering starts at 0, 1, 2, 3. Okay.
Mm-hmm.
So my fourth element is 3. Or if I want to
Mm-hmm.
count from right to left, I can go counting backwards also. If I want to do that, this numbering starts at -1, -2, -3, -4. Okay. So let me show that as an example. So instead of cherry, and then let's say apple, banana, cherry, orange. Okay. So these are the four elements. If I want banana going forward, I have to get the first element of the list. Okay, because banana is 1. But if I count backwards, banana is -3. So I can write my list or -3 and it will give you the same value.
Okay, -1, -2, -3. Okay.
Okay, so you understood this concept, right? So
Yeah.
this is how it is. So when you go from left to right, it will go 0, 1, 2, 3. It will start at 0. But if you go from right to
Mm-hmm.
left, it will start at 1. That is -1, -1, -2,
Mm-hmm.
-3, -4. Make sure
Mm-hmm.
you remember this. You write it down in like in your bones. You don't forget this because if you forget this, you'll break your head why something is happening, why something is not happening, and all that. Okay.
Mm-hmm.
So now let's go back to code. So this operation that you see, okay, let me just go back. This operation that you see is called as indexing. Okay. So indexing means you are going inside this and getting the value that you want.
Mm-hmm.
Okay. Single value that
Mm-hmm.
you want.
Mm-hmm.
Okay. Next. There are, what else can you do on a list? You can find how many elements are there on the list. Okay. Length.
Mm-hmm.
Length of a list. So the simplest way of finding number of elements of a list is length
Len.
and mylist. This is a function that is predefined. Someone has already written the code for you. You don't need to know what is it. But basically, you can say
Mm-hmm.
length of my list means it will say, okay, the length is 4 because it has 4 elements in it.
Mm-hmm.
Okay. So length is something that you have understood. Are you clear
Yeah.
on that?
Yeah, yeah.
Okay. So if you anytime want to look at what is a variable's type, how do you do it? You use a function called as
Mm.
type. Okay, type, and
Type.
if you give any variable, it will tell you exactly what it is. Not necessarily
Mm.
only variable. For example, def something here. Okay, return none. Okay, I've defined a very simple function where it does nothing. So I can do type of this also. It will give me something. Here is a function. So type is a
Mm-hmm.
variable that will tell you exactly what you can do. Okay. Now,
Mm-hmm.
okay. So you have worked on length function, which generally people use to identify how many elements there are.
Length.
Okay. Then you have used
Mm.
type function to identify what is the type you want. Then there is another function which I never discussed with you is called as dir function. Okay. What dir
Mm-hmm.
does is let's type dir bracket open and give a variable name and close. Okay. For now, ignore all those double underscore things. Ignore them for now. Okay. These are called as
Mm-hmm.
magic methods. We'll come to them when we discuss classes. Okay, these are even
Okay.
class itself is an advanced topic. This is advanced topic within the classes itself. Okay, we'll not
Mm-hmm.
touch those right now. All this underscores, these are called as dunder methods also because it has double underscore in front and double underscore in back. The double underscore is called the underscore dunder, called as dunder methods or magic methods or something like that. For now, don't
Mm-hmm.
break your head on what this is. So see
Mm-hmm.
these, so you can do all of these actions on this list. So any variable that you do, you give here, it will tell you what things you can do on top of it. So let's look at each one of them. Okay, I'll just
So do we
comment
need to
them.
memorize this?
Yes and no. You don't need to memorize this because you can always type dir and then get what are all the things that are there. But in usage, you keep it using it more as frequently, and you generally memorize most of them.
Mhm.
Okay. As you keep writing code, you will memorize it. So you don't. So how do I explain this? You will memorize it, but you don't need to memorize it. But effectively,
Mhm.
everyone memorizes it only. Okay. You don't need to because it is always available. Also, there is another
Mhm.
method called as, there's another function called as um, help. Okay, you can do that also. It will tell you exactly what are all the things that are implemented, and it will give you like full data. It will give you like, for example, um, so for example, here it says if you do append what it will do. So append what inputs it will take, what it will do. Clear what inputs it will take, what it will do. Copy what inputs it will take, what
Mhm.
it will do. Okay, so you can use this
Mhm.
also to understand exactly what it will do if you want some kind of things. Okay, generally
Mhm.
we rarely use it in practice. Okay, but it is there
Mhm.
when you want to use it. So let's look at each one of them
Mhm.
in here. Okay, so append, if you see help my list dot append. Okay, it says append. What it will do is it will append object to the end of the list. Append means add. So add
Mhm.
object to the end of the list. And in input, you have to give an object or more than one object. Okay. So you have to give an object as an input. So what basically it does is you have to write my list. Okay. Dot append. So until now you have
So you
written,
need to use dot.
yes, until now you have written like functions. If you are calling it, you are calling it like length of my list. Okay, like
Mhm.
this, right? But when you do
Yeah.
dir and you get this, all of these you will call after the name.
Mhm.
Okay, my list dot, and then see here it gives all of these same things here. Okay,
Mhm.
all of these are only here, so you can do all of this here. The difference is that it works almost exactly similar. Okay.
Mhm.
Okay, it also you give like open bracket, close bracket, you'll give arguments inside exactly like you do for functions, but these are not
Mhm.
functions, these are called as methods. Okay, as of
Mhm.
now, you don't need to understand the difference between function and method. Only difference is that method you will call it the variable name dot, and then you will give method name and then the values. On functions you will not call like that, you will directly give. So imagine if append was a function, instead of like this you will call like this, append of my list. Okay, this is how you will call a
Mhm.
function, this is how you will call a method. Okay, this is the
Mhm.
only difference right now you have to understand. Actually they are same
Mhm.
implementation, but basically we'll discuss on what a method is later on. But as of now, assume it is same as a function, it does exactly what a function does, but it is written differently, that's all. Okay,
Mhm.
so here it says give an input to append. Okay, what is that input? Okay, let's say for example I want to add um tell me a nice fruit name, mango. Okay,
Mhm.
when I add it, what will happen is if you see my list now has a mango at the end. So if you had
Mhm.
seen help of my list dot append, okay, it says append object to the end of the list. Always at the end it will add. Whatever if you want to add at the
Mhm.
end, you will use append. Okay.
Mhm.
Now let's say clear what it will do. Okay. Clear removes all items from the list. Okay.
Mhm.
So if I say my list dot clear, what will happen? So when I
It
say
will
my list
remove.
dot clear, if you see my list has become empty now.
Yeah.
Okay. Let me rerun this here so that I'll get all the elements back. Okay. And let me just remove this one so that it will not clear. Let me just comment out so it will not run. So now if you run my
Yeah.
list, you will have all four elements right now. Okay.
Mhm.
So clear, you understood what it does. Then
Yeah.
copy. So let's see what copy text what text for copy. What does it say? It says returns a shallow copy of the list. Okay.
Mm,
So for now, this shallow copy and deep copy are two different things. We'll come to it maybe a half an hour later. Okay. So basically, you'll get a
mm,
copy of the list. So for example, I'll say my list two is equals to my list dot copy. Then I'll have my list two here. Okay. My list two dot append. What happens is mango. Okay. Now if I do my list two, my list and my list two. Okay. Here you can see the difference. What I'm doing is my list dot copy I did. What happens is it
mm,
will take all the elements of this list and it will store it in a separate location.
mhm.
Okay. And that it
Okay.
gives a different name. So when I change something on my list to, nothing happens to the
Mhm,
original thing. Original thing remains same, but the new thing has
mhm,
changed. So for example, if I do my list to dot clear also, let's say dot clear. So methods you can do like this. You can apply this and then something else and something else. You can append, keep keep adding on top of each other.
Okay.
Okay, there's that advantage. Okay, okay, fine. It's not allowing you to do. Okay. Okay, it'll allow you to do in some cases it won't. So for now, let's not break our head why it won't do. I'll, I'll explain that topic also later. Okay, let's say if I do clear on my list two, it will not change the values in my list, but all elements in my list two are gone.
Mhm,
Okay, so clear copy
okay.
you have understood. But remember, this copy is a shallow copy. Remember this in your head
Okay.
right now. Okay, what is shallow copy? What is deep copy? We'll come to it in some time. Okay, so next thing is count. Okay, my list dot count takes one argument, zero were given. Let's say what does this count do? What it will do is it will take a value, return the number of occurrences of that value. Okay, so for
Mhm,
example, I'll say my list dot count mango. It will say zero because there are no mangoes in my list. Correct.
okay.
But
Yeah.
if I let's say cherry, it will say there's one cherry in your list. Or let's say if there were five cherries in my list, it will say five cherries in your list or something like that. Okay.
Mhm,
So imagine like you have a okay physics scores for first year students. Okay. And let's say out of 10 students, they got marks like 9, 8, 7, 9, 5, 3, 10, 10, 7. So in a class of 10 students, 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's add one more, let's say 8. Okay. In a class of 10 students, based on the roll numbers, the first guy has 9 marks, second guy has 8 marks, third guy 7 marks. If you want to find how many people got tens, you can do physics scores first year students dot count 10, and it will tell you two people got 10 marks.
mhm,
Okay, so you find the use of count. Okay, next extend. What does extend do? You can go to help and see what does it do. It will take an iterable and extend list by appending elements from the iterable. Okay, so for example, um, okay, I'll create a my list two as a copy of my list. Okay, then what I'll do is I'll say my list dot extend my list two. So I hope you understand what will happen here,
yeah, it will add both the list.
kind of. So what it'll do is it'll take all the elements of this and add it to the end of first one.
Mhm,
Understood?
yeah.
So extend will extend one of them by adding everything else from other one. Okay. Then what else is there? Index. Okay. So for example, in this one, let's take physics first score first year students. Okay. Let me write a simple variable instead of such a long variable, so I don't have to call it every time so big. Okay. Score.
Mm.
Okay. Now let's say I want the student who scored 8 marks, at which position it is. So, for example, assume these are roll numbers 0, 1, 2, 3, 4, 5. Positions are roll numbers. Or find out the student who scored 10 marks. Okay. So, score dot index of 10, if I do, it will give you 6 here. So, that means go here 0, 1, 2, 3, 4, 5, 6. Sixth one is
It
10.
will give the first one.
It will always give only the first element. Even if there are n number of repetitions,
Mm.
it will only give the first element if you do
Mm-hmm.
dot index. Okay. That is the drawback of dot index.
Mm-hmm.
Okay. So it will help you to get the first occurrence of the place of where it first occurred, the index of when it first occurred, you
Mm-hmm.
will get it. Okay. Then insert. I hope you now can tell me what insert will do.
It will insert any object.
It will
Matlab
insert any
element.
object, but append will also do it, right?
Yeah.
So here you can say insert will take two arguments. First one is index, second one is object, and it will insert object before index. So for
Mm-hmm.
example, if I wanted to insert
Append
another
will do
score,
in the end.
yes.
This
So for
one.
example, at
And
the sixth position, I wanted to insert, let's say instead of 10, it should be 4, let's say. Okay. So at sixth position, insert 4. If I do, and then run, see the score. If you see now, it will say the sixth position is 4, seventh is 10 now. So it will move everything else to the right after that, and at that position it will insert the value. So
mhm.
0, 1, 2,
So
3, 4, 5, 6. Yes, tell me.
so first for the insert, you have to write the position and then what do you need to
Position
insert?
and then what do you need to insert? So for example, if I write this like uh, uh, Python class, okay, like this. So now what it will do is it will take these everything that is after that, it will move it to the right and in between it will insert. So now what it will do is
Mm-hmm.
it will insert in between and move everything to the right.
Mm-hmm.
Okay. So insert you have understood. Next pop. Alright. Pop what it does is it removes an element from the list and gives it to you. That is the difference between pop and remove. Okay.
Mm-hmm.
So for example, if I want to remove this Python class, okay. So what I'll say score dot pop and I'll say
Python class.
no, not Python class. I'll give its index at position 6.
Okay.
Whatever is there at position 6, remove that. And see, until now, whenever I run something, it will not give me any output here. Okay. But here
Mm-hmm.
what happens is it will return that value to you. It will give you that value separately.
Before running it.
No, after it removing it, it will give that value to you. So if I run score now, Python is not there, Python class is not there in this, but that value is given to you separately.
Mm-hmm.
So pop is a very, very useful method used especially when you do things like, for example, what is a good example to tell about pop? Um, you have to run it once, but once you run it, it has to be not be there in that list, kind of things. Okay. It's a good example. So what generally people will do is when you pop something, okay, you will store
Mm-hmm.
it because it gives you, it returns a value to it. You can store that value. Okay, pop value is equals to score dot pop and sixth element.
Mm-hmm.
Since now Python is already removed in this list, now 4 will be removed and it will be stored as pop underscore value. So if I run pop underscore value, that is 4. Okay, because it is removed it and given that value to you. Okay, and if you see score, it says same thing 9876953101078, which was the first thing that we started with. Exactly same, but the only difference is that score dot remove will remove the value. So here you are telling which position you have to remove, and it will remove the value at that position. So you are passing the reference here. Okay. So now you hope you understand. We are passing the index here.
Mm.
So you are telling at whatever is there at fixed position inside my list, remove that.
Mm-hmm.
Okay. Here, when you say dot remove, you are saying remove 10 from my list. So what it does is it will remove the value 10 from your list.
But it
Yeah,
won't give you.
it will not give you first thing. It will just remove wherever it be. It let it be at the starting. It let it be at the end. It will remove the first instance of that number. So what it will do is it will do
Mm-hmm.
first. It will do dot uh, index and then remove that value from there. But it will not give that value
Mm-hmm.
for you. Basically, remove you will give the value. Okay. In pop, you will give the index. So this is an example of pass by reference, pass by value. Here, here you
Mm-hmm.
are doing pass by reference.
Okay.
Okay, so this is the difference. So this explanation, hopefully you have understood. So
Yeah.
here you are not referring to the value, you are referring to the place and saying whatever is there at that place, remove that. Here you are saying remove this value from the list.
Okay. If you remove the value, it will
Mhm.
remove only the first value,
First
or it
instance
will
of that
remove
value.
all.
That's all. Only first instance.
Mm-hmm.
Okay. Then you have something called as reverse. I hope it's self-explanatory what it'll do.
Yeah, it will reverse the list.
Yes. Not remove, reverse. So it will reverse. Listen to this. It will reverse it in place. So if I
Mm-hmm.
say, for example, my list. Okay, my list. Let me rerun this my list. Where is it? My list. Okay, my list. And now, for example, if I see what are the elements in my list, there are apple, banana, cherry, orange. If I do my list dot reverse, okay,
Mm-hmm.
then what it will do is it will reverse the list in place. That means the original list is lost. It is overwritten by new
Mm-hmm.
list. Okay, so whatever here it was orange, cherry, banana, apple, it is written in return now. Reverse now, sorry. And it overrode the first list. Okay, understood? And then finally it is sort value. So sort value, what it will do is, okay, let's do dot sort, then we'll discuss on what it will do. Okay.
Mm-hmm.
So right now, my list says orange, cherry, banana, apple. When I do dot sort, if you see again, it will do on in place. It will do okay. And if you see right now, because A is smaller than B, so in text, in numbers, I think sorting. It will do it in ascending order, basically always. Okay.
Mm-hmm.
So for example, if you have score, okay. So let's look at score. Score is 98795310778. But if I do score dot sort, okay, and then see what is the score, it is 3577889910. Clear? It
Mm-hmm.
is going from the smallest element to the largest element in ascending order. Everything is sorted.
Okay.
Okay. But if you look at how it will sort is, it will always take A before B, B before C, C before O.
Okay.
But imagine if your list has an element called, instead of apple, let's say AAPLE. So just one more I'm adding, just so that you'll see what happens when you sort it. So my list dot sort my list. If I do, first what it'll do is here it'll look at first A and A. Since these both are same, okay.
Mm-hmm. Then
Since
it will go for second letter.
second letter exactly. So what it'll do is it'll look at apple and APPLE, apple, let's say, okay. So what it'll do, it'll
Mm-hmm.
compare these first, it'll try to compare first elements. If it is able to do within first elements everything, it will say, okay, I know this is first, then this. But here I don't know. These two are same. Then it look at second elements. Then it will say, okay, this is
Mm-hmm.
faster than this, so I'll take this one first. This is second, and then other things.
Mm-hmm.
Okay. So
What about if there is a means like integers also in that?
we can add and see. Okay. So good question. Let's add. So my list, where is my list? Actual list here, right? Orange. Let's add 2, 2 comma 3 comma 2.5 comma 30 3.5. Okay.
Mm-hmm.
Just only these things. Let's add everything. My list dot sort bracket open close and my list. If you see, it says this is not supported between instances of integer and string. Because it has different types of things, it is not able to do it.
So
For
we can't use
sorting to
sort
work,
in this.
it prefers if everything is of same type.
Mm-hmm.
Okay. But you can do this if you want. Everything as string. Now it will work. See 2, 2.5, 3, 3.5, apple, banana, cherry, orange. So the digits are, if they are digits within a string, they are taken given precedence over the string values itself. Okay.
Mm-hmm.
So these are all the methods that you can use. I'm not saying functions. These are all the methods that you can use on a list. Okay.
Mm-hmm.
Because you are doing things to, so for example, here, let's say pop, you are taking a list, you are taking the sixth element out of it and then saving the list again. Okay. You are editing the list. You are making changes on the list because list is mutable. Okay. Now,
Mm-hmm.
it has an unmutable cousin called tuple, right?
Apple, yeah.
So let me take the same thing. Let me just remove these unnecessary things for now. Okay, let me take this list and let me create a tuple out of it.
Mm-hmm.
Okay, instead of my list, let me call it my tuple. Just naming convention, I am giving tuple. It you could give anything. Okay, instead of list, I'm saying square brackets. I'm saying round brackets. And if you see
Uh,
now, type of my tuple, it is a tuple.
mm-hmm.
Okay. Now, especially if you do dir of my tuple, you can see you can do only two things on this. You can count, you can do index. That's all. You cannot
Mm-hmm.
change, you cannot reverse, you cannot insert, you cannot remove, you cannot pop, you cannot do any of those things. So these two things
Mm-hmm.
do not change the tuple. These two things add value to tuple. So you'll count how many times apple is there or count how many times banana is there. That's all. But you'll never change the values inside tuple because tuples are
Mm-hmm.
immutable.
Immutable.
Okay. So that is the difference between list and tuple. Okay. So one thing I wanted to show is so there is a way I'll just show you the difference why sometimes people prefer to use this over the other thing. Okay. So still my list and then my tuple. Okay. It stores the same information, correct? Okay.
Mm-hmm.
Let me just redo this to store exactly this one. My list is equals to this. Okay. So if you see now, my list and my tuple store exactly the same information in the same order. Correct? Only thing is that
Yeah.
in this you cannot do any changes. In this you can make changes. You can add things in between, at the front, at the end,
Mm.
wherever you want.
Yeah.
Okay. So the okay, now what I'll do is there is something called as import sys dot get size of. Okay, you don't for now we'll not go into this, but you can do this to see what is the number of bytes it is taking to store this value in memory. Okay. So you're storing
Mm-hmm.
same information, exactly same information. But the size when you store it in tuple versus when you store it in list, it is way different. So here it is 88, here it is 72. For four elements list, it is not such a big uh, issue. But imagine, let's say, for example, my list into 1000. Okay. So now if I just see what is my list, it is apple, banana, cherry, orange, apple, banana, cherry, orange, repeated, those four elements repeated 1000 times. So if you see the
Mm-hmm.
length of this list, okay, it is how many elements? 4000 elements inside this list.
Yeah.
Okay. And I'm creating a tuple that is a full variation of my list. Just so that you will understand why it might be a different thing. Okay. So here what I'm saying is take my list and convert it into a tuple and store it in this variable called my tuple. So exactly now if you see now my the length of my tuple is also exactly the same. It is exactly the same as tuple is the same as the my list. All the values are there here
Mm-hmm.
also. But now if you see the length, the space it takes, here also it is not as different. 32,056, 32,040. Let's increase it further. Oh no, it's already big. So let's not do this. Still, it's not changing too much. Why? Generally, the thing is, I'm not able to show within, even if I'm going to, let's say, 44 lakh elements inside my tuple also, it is still showing similar memory, but actually there is a memory difference that you will be able to see here. I'm not able to show it to you right now. But generally, this carries less overhead because you can do very less things with this. You can just store information. So tuple can be used
Mm-hmm.
where you just want to store information and just look at that information. You don't want to change that. Like,
Mm-hmm.
for example, you have employees name, employees ID, employees um, full name, employees email address. These things won't change whenever employee is within your company. So those can be stored as tuples. But things like, for example, his salary, his department, his position, those can change. He can become engineer to senior engineer to something else. So those can change.
Mm-hmm.
So those kinds of things you will not store within a tuple. You'll try to store within a list because you can modify those in future. Okay.
Yeah.
Just kind of an
Okay.
example I'm just giving you. So when you can use tuple
Mm-hmm.
versus list. So you have understood indexing, you have understood
Yes.
different methods on lists, okay, on
Mm-hmm.
tuples. There's
Yeah.
one topic which I haven't touched right now is called as slicing.
Mm-hmm.
Okay, so let me go back to top. Let me explain slicing in the top itself. Okay, let me run this first. Okay, let me clear everything. So all my memory is free. I don't want to store all this big size things. So I'll just remove everything from here. Okay, just I'll delete everything from here. Okay, now if I run this first one, you have a list. Okay, my list. Okay, this is here. Now let's look at slicing. Slicing, what do you understand by slicing? Just from the name,
By cutting down.
cutting down exactly. So what you'll do is you'll try to get in. If you want to get one element out of it, you'll get the element, but you have to get, let's say, apple and banana. Okay, what you will do is you have to
Mm-hmm.
get element 0 and element 1. Okay, so if you say my list, uh, similar to indexing, you'll have same brackets. You have to get 0th element and first element. Sorry, 0th element and first element. So you are getting this one. Okay,
Yeah.
so there is a concept called so in index what you will do is you will give the name of variable, then bracket and then position. Okay,
Mm-hmm.
this is called as indexing.
Mm-hmm.
In slicing you can give three parameters: name, start, end, step. Okay. So you can say start at 0, end at 5 in a step of 1. Okay. So hope you are able to understand what I'll be doing. So what it'll do is it'll start at 0, and the difference here is make sure you remember this again. This is like put it in your bones. You have to remember this. This is inclusive. Okay. This is exclusive. So what it means is, okay, start at 0. So you'll take 0th element, 1,
Mm-hmm.
2, 3, 4. Since it is exclusive, you will not take 5 here. Only these 4 you will take. Okay, clear?
Yes.
And here, since the step was 1, you will do 0, 1, 2, 3, 4. Imagine if step was 2 here, you will do 0, 2,
2,
4.
4.
That's all. After that, 5 you will not again take. You have understood how how this is used? Okay,
Yes.
this is a very, very, very powerful tool on working on lists or tuples or anything. Okay,
So we can do slicing for tuple.
tuples also. So basically, you are taking a copy of it. You are not so like indexing. So when I index to 0th location, okay, I am seeing what is there inside that. I am not doing anything to it. I'm just seeing what is there. Correct? Hello?
Yeah, yeah.
Yeah. So even for tuple also you can do. So let me create a copy of it called my tuple. Okay, and let me go round bracket and round bracket. Okay, so I can do the same thing instead of my list. I can put my tuple and do the same thing. It will give you that 0th value, or I can do 0 to 2. So it will take 0th value, first value, and it will give.
First one.
Okay.
Mm-hmm.
So here, if you see in OneNote, when I have shown you, I've shown it will start at 0. Okay, it will always. So the let me just go to a new page. Okay, your name of the data structure, list or tuple or string also you can do. For strings also you can do. Okay, and then
Mm-hmm.
you'll take start value colon end value colon step value. This is what you have to define. Okay, this
Mm-hmm.
is inclusive. Okay,
Mm-hmm.
this is exclusive. Okay, this is default is default is 1.
Mm-hmm. One.
Okay, we'll come to defaults 1 second later. Okay, I'll come to defaults. Give me 1 second. We'll go there. Okay, now, so what do I mean? So for example, if I say x, there is a list called x, go from 0 to 10. What does it mean? What all values I'll take? 0, 1, 2,
One,
3,
two,
4,
three, four,
5,
five,
6,
six,
7, 8,
seven,
9.
9.
Okay. So this is how it works. Okay. But if you
Mm.
see here, I have excluded this second thing, and colon 1. If I add it or not, it is the same thing actually, because there are
Mm-hmm.
some default values. So
Okay.
this, the default value of this is 0. Okay.
Mm-hmm.
The default value of this is the end of list. Okay, end of length. Okay, what do I mean by that? I'll come to it 1 second. The default value of this is 1.
1.
Okay, so if it is 0 to 10 out of 20 elements, okay,
Mm-hmm.
so I can just write x of colon 10.
Right.
I don't even need to
Okay.
write 0 because this default is taken 0.
Taken. Okay.
Okay, so this will also give exactly same answer as this. So that is where
Mm-hmm.
I am not writing the step value anywhere here when I showed you.
Mm-hmm.
Unless you want to
Okay.
step it a different variation, you will not write it only.
Okay.
Okay, so this will also
Yeah.
do this. Or if I do x 0 colon, what does this do?
It's the same to the end number.
No, it will take up to 20 numbers, it will take everything. So it is basically same as writing directly x. So it will start at 0, it will end at this number.
At end number.
It will end at the end number.
Yeah.
Or let's say if I do x5 to like this, what does this mean? It will start at 5, then go 6, 7 until
Mm,
it goes to 19 because you have 20 elements in your list, right?
20.
So until
Mm,
19. So it will do this. It will take all of these values and it will put it. So if you want to go until the last element, you will just leave it empty.
mm-hmm.
Okay. If you want to go from first element, you will leave the first thing empty. So what if I
Yeah.
write x like this
It will take from 0 to the end
to
element.
end? So it is as good as taking everything in x. So this means
Mm,
everything in x.
yeah.
Okay. Next.
Mm,
So this is clear, hopefully.
yeah.
So x. Let's say I say 3 to 8. What it will take? 3,
So it will start from
4,
3, 4,
5,
5, 6,
6,
7.
7. That's it. Clear on this?
Yes.
There is one thing I didn't tell you. You can also do x of -1 to -4. You don't need to go positive only. You can go negative also.
Mm-hmm.
Okay. In that case, again, the step will be -1. Instead of 1, it will be -1.
Mm-hmm.
Okay. Or this is the one that generally people use, and even I forget what is this. I'll have to search and then I'll remember. Colon, colon, -1. What will this do?
Stepping.
It will step, but how? You are going from start to end, but you are going in the wrong direction. That means
Mm-hmm.
it will reverse the list actually. Instead of dot reverse, you can
Mm-hmm.
use this itself directly.
Mm-hmm.
Okay, let's go back to VS Code. I'll show that just to show. Okay, so you can do colon colon -1. It will write exactly in orange, cherry, banana, apple. So that is what is written. Even if without using this, if you do dot reverse also, it will do the same thing. Okay, this is a shorthand way of doing it. Colon colon -1. Or as I said. So
Okay.
for example, let me add few more here just so that we can. Okay, apple, banana, cherry, orange, mango. Okay, let me add few more. Carrot. What else? What else? What else? What else? Um,
How did you add both together?
in VS Code, there's an option called multi-line addition. So I'm doing that right now. So you can press Alt and select multiple locations. In the same thing, I can add multiple locations also at different locations I can do. So it'll add
Mm-hmm.
multiple cursors here. You can see two cursors are blinking instead of one.
Yeah.
Okay, carrot, radish, let's say potato. Okay, let's say what else? Burger. What else? Pizza. Just adding few elements
Mm-hmm.
so that we can slice and dice different ways just so that. Okay, so for example, if I want my list, my output to be orange and carrot, what should I do?
Orange and
Carrot.
carrot. Uh, z- my list. So
So
zero,
count
one, two,
zero,
three,
one,
three.
2, 3. Okay, 3. Okay, where should I end?
Mm. Uh, so you want just the output orange, right?
Orange and carrot I want.
Okay. Uh, 6.
3 to 6, okay? And step twice
Mm,
I want.
okay.
Then it will give you orange and carrot. If you don't step twice, what will happen? It will also give you mango.
If mango.
You have to skip mango, so you'll say from 3, but jump 2.
Mm-hmm.
Start from 3, go until 6, jump 2. This is how I read it generally. Slicing, this is how I read it. Start from 3 until this number, jump this many.
Mm-hmm.
Okay. So,
Yeah.
so for example, if you want potato and radish in this order, potato and radish.
So it's minus now.
Yes. Either there are two ways you can write it. Okay. You can say 0, 1, 2, 3, 4, 5, 6, 7. So 6 to 8. Okay. 6
Yes.
to 8, but go in reverse. Okay, it's not giving for this one. It's not doing this. Okay, fine. So it's not working. If you write minus in step, you have to give this also negative only, I guess. Okay,
Mm-hmm.
so you have to say minus 1, minus 2, minus 3, minus 4, minus 5. So minus 1, minus 2, minus 3, and minus 5. Okay, so this
In
should
this,
be
we don't need
minus
to
3.
put extra, right?
Sorry.
Like how we were taking here, uh, like the 0, 1, 2, 3, 4, 5. If you want carrot, so you want to have use till radish.
Yes, here also you are doing. So that is why I said this is minus 1, this is minus 2, this is minus 3. So I'm starting at minus 3. I need minus 4, so I'm going up to minus 5. So I'm saying up to minus 5.
Okay.
Start at minus 3, go until minus 5 in minus 1 steps. So everything should be in minus if you are writing minus.
So how to know the length of in minus?
What length?
Like a length of this list?
No, you do. If you write
Yeah.
like this, what it'll do is it'll start at minus 3. So pizza, burger, potato. It'll start at potato and go until it reaches the end. So it'll
Mm-hmm.
start with potato, radish, carrot, mango, orange, cherry, banana, apple. That is what it'll write. If you leave this empty, it'll go until it reaches the end in whichever direction.
Mm-hmm.
If imagine this was okay, let's take this one also out. So imagine this was plus one. What it will do is it will basically go from here until it reaches the end. If this is
Mm-hmm.
minus one, it will start at the end, it will go until it reaches the start.
Mm-hmm.
Okay. So this is a very, very, very useful tool where you don't have to do all this method calling and other things. Slicing, it is called as slicing and it is very useful and it's a shorthand that you use very often. Okay.
Mm-hmm.
So this is another topic. Um, I think most of things that I wanted to cover, I have covered except for shallow copy and deep copy. Okay.
Mm-hmm.
Do you want me to go to that topic and then close or what?
We can take that tomorrow because
Yeah. Okay.
I'll be
Just
confused, like
yeah,
in
yeah.
this.
So just so that whatever I told right now can be done on string also. For example, my string, I've just copied a string. Okay. This is a string.
Okay.
So string is a sequence of characters. So if I tell take the, for example, my string, okay, take the which one? 0, 1, 2, 3, fourth element. So let's say I wanted this name. Okay. So it will
Mm-hmm.
be fourth element to, okay, fourth element to, let's say 25th element. It will say k nearest neighbors and these two it's taking. So until 23rd element, let's say. It's giving exactly k nearest neighbors. Okay. This also, instead of comma separating here in string, it is each letter is a value.
Mm-hmm.
Okay, so that is the only difference in term. It's not difference. String itself is a it's a sequence of characters. So you can treat it
Mm-hmm.
as such. You can index into some values if you want. For example, um, let's say 250th value is space. Let's say 251st value is p. So some t, either this one or something it is 251 to end. Let's say so that means this line.
So we need to use square brackets list.
It's the indexing. Basically, what you're doing, indexing and slicing, same thing you're doing in string.
Mm-hmm.
Okay. So
Like,
your
I
home,
mean, you can use round brackets also for indexing.
no, you need to use square brackets because imagine if you use round brackets, what does it look like? Does this look like a
Mm,
function definition?
yeah.
So Python will think, where is the function called myString when you if you give like this?
Mm-hmm.
So it'll say, or it'll say, this is my string. You are trying to call it. I told you, right? When you call a function, so it is trying to call and it's saying, Array, it's a variable. Why are you calling? It is not callable. You cannot
Mm-hmm.
call it. So it is trying to do function things to it if you give round brackets. That is why square
Mm-hmm.
brackets are needed.
Mm-hmm.
Clear?
Yeah.
Okay. So your homework for now is if you do dir on any string, okay, you will get some things here. Okay. Let me
Mm-hmm.
just delete all of these things so that we'll only look at those things. Okay. How you do that?
Okay.
Okay, there's one more topic I forgot to tell. X for X in dir of my string. If um underscore not in X. This is what I've written is called as list comprehension. This is a advanced topic of list. It's a simpler way to write a list. Okay. But it's not necessary that you need to know this.
Mm-hmm.
Yeah, I would suggest or prefer if we park this topic until we come back to it sometime after you are well versed with working on lists. Okay,
Mm-hmm.
so for strings, if you see, these are the different things that you can do on strings. Okay, your homework is try doing slicing and indexing on a string. Take any random string. Okay, it could be your email address, something. You can do that. Then try understanding what any of these will do. Okay, there are multiple things that more than what it is there for list. Okay, you can capitalize it, you can case fold it, you can center it, you can count something similar to list count. Okay, encode is something. Encode and decode you leave it for now. Okay. Okay, then you have
Mm-hmm.
other things you can do. So just go through all of this, as many as you can. Try to understand what it is. Then we'll discuss
Mm-hmm.
tomorrow on strings. Okay,
Okay.
so things that I wanted to cover today, which I did not cover, are okay. Strings, complete topic I have to cover. Okay, so then you have list comprehensions. You need to do list comprehensions. And we need to do one more topic called what was that called? I forgot it. Let me just remember. List comprehensions and shallow and deep copy. Okay,
Mm-hmm.
these are kind of advanced topics, and generally when you keep working with lists, as you keep doing more things, you will find there is an issue that happens because of the shallow deep copy things. So that is something we'll come to
Mm-hmm.
it when we come to it. Okay.
Mm-hmm.
So strings, your homework for today is find, apply as many methods on strings and come back with list of methods that you are you need explanation. Okay. So what
Mm-hmm.
you should do is look at each of them just so that I close this topic clearly. So for example, you take a string, let's say let's say my name itself is, or your name itself is a string. Okay. Let me just go to my VS Code here. Okay. So for example, uh, let's take, okay, my string is equals to Python is a good language. Okay.
Mm-hmm.
Now try doing many things. Like for example, my string dot. Let's say you have let's say is alpha. Okay, you can try what is this. Is alpha. Dot is alpha. It says false. When will it be true? Try finding it out. Okay. Or it says is digit. Okay, it will be false again. When will it be true? Or it says dot lower. So everything here is written in lowercase. Or it says dot upper. Okay. So see
Mm-hmm.
everything, whatever written here, it converted into capital letters. Or
So
it
here we
says
need to
to
use the round brackets.
methods. All of these are methods.
For the methods, you need to use round brackets.
Yes, methods is same as functions. Only difference is that in methods you will write name dot something, dot and method name.
Mm-hmm.
Okay, this is how you will write.
No, no, I mean we are writing dot, then after that we are using round brackets, right?
Yes, it is same as function. So function how you will call, similarly method you will call.
Mm-hmm.
Only difference is that in function your call would be method name of my string. Okay.
Mm-hmm.
Actually, this, if you are calling it like this, what actually happens is this thing only happens in backend.
Mm-hmm.
But why you are writing it like this, I'll explain it to you when I explain classes, why methods and how it differs from functions. Until until that
Mm-hmm.
point, your only thought process is methods and functions do exactly same work. Only thing is the way we call it is different. Until you come to why we write methods and why we write functions, where we'll use method, where we'll use functions. That point when we come, when we are talking about object oriented programming and class definitions and all that things, very good stuff. When we
Mm-hmm.
discuss that, we'll explain in detail what it is. Until that point, your only thought when I say method or function, the difference is method you will write it like the first line here, function you will write it like the second line here. That's all. Both of
Mm-hmm.
them do exactly same things. Okay.
Mm-hmm.
So until that point, so keep in mind they are different, they have different purposes, but they do almost similar work. Okay. So
Okay.
until you understand what a method is and what object-oriented programming itself is, you will not break your head on why method or why function. Until that point, both of them are exactly same. Only way you write is different for both of them.
Uh-huh.
Okay.
Okay.
So that topic
All right.
mostly, if you can, we'll try that topic. Uh, okay. So the thing is, tomorrow's class is important. If possible, ask everyone to join tomorrow's class on strings, because most of the time we'll be working on strings, with strings, and all those things. Okay, that is one thing.
Mm-hmm.
After strings, we'll talk about files, working on files, working with files. There is one more, few other keywords which I did not tell you right now. Okay, so if you look,
Mm-hmm.
okay, what you can do is you can go to Python W3 schools.
Yeah,
Okay.
I'm going through that too also.
Yes. So you can see what are all the topics here on the left. Okay. So
Yeah.
I've already told you syntax, comments, variables, data types, numbers, strings. Casting is something which I've explained, but I did not tell you. Okay. Typecasting is what I've told in one class, but I did not explain in detail on casting, because as of now to use you don't need it right now. Okay. Strings,
Mm-hmm.
I'll tell you tomorrow. Booleans, operators, lists, we have done all of this right now today. Okay. Then you have tuples, which is almost exactly like lists. You can run through them. Okay. So only difference is that tuple methods are count and index. That's all. You can okay, loop and all that we'll see. Okay. Then
Okay.
sets, dictionaries, all of this, okay, we'll come to them. If else, while loops, for loops are done, functions are done. Lambda will park it for now, will not touch it. Okay. Arrays, Python arrays, what it does, it exactly takes same thing, which is a list. So in Python, there is no built-in support for arrays. It is just Python lists are used instead. Okay. Then comes class and object and inheritance and all that. Okay. These four, five, these four topics are advanced topics. Then again, scope is something which you have discussed today. What is the scope of a variable?
Mm-hmm.
So a variable created inside a function is available inside that function. That is called local scope or functional scope. Then there is global scope, which I have defined. So variable not defined inside a function, but within a file has global scope. Okay.
Mm-hmm.
So I've given you this exact example, right?
Yeah.
So you can run, understand this one. This will give you some understanding. Then what I
Mm.
want to do next is to go for here they didn't file handling. This topics I want to touch. Okay. Here there is something called as open keyword, and there is another function. There is a deconstructor function called as with, which we haven't discussed until now. Okay. So those things are good things which I want to discuss
Mm-hmm.
next. So we'll complete strings, then we'll go to file handling. Okay. With this
Mm-hmm.
complete, once you complete file handling, you should be able to write 90% of anything. Okay.
Okay.
Any function, any program, most of the time you will be able to write with all of these complete. Okay. Then
Mm-hmm.
when I come to other things like casting and then lambdas and then inheritance, class, objects, iterators, these are kind of efficient ways of doing it. Kind of. Not exactly that, but these are like more better ways of doing in some cases. So sometimes you can write something as a class or an object where it will give you some power to do. Writing it this way will give you some advantage. You can do it
Mm-hmm.
without this also, but it will become more complicated. You might have to write 10,000 lines, while if you write it as a class, it will be easier maybe or something. So
Mm-hmm.
it will give you some advantages. Then inheritance is a topic which is closely linked with classes, so you don't have to break your head on that. Iterator is basically, yeah, it is. We can touch this also actually tomorrow while we, because we'll, okay, you can go through this thing. Where is this? Mm, iterating. Okay, in pupils it is there. So you have this called loop pupils, right? So you can
Mm.
just understand what this is.
Mm-hmm.
Okay, what it does. Okay, so just go through this. This is something which you already know, hopefully, but you can go through this and understand what this is, your range and length and all of this, what it will do. You can see. If you don't
Yeah, I
know,
want means range. I wanted to
yes.
know.
So
Mm-hmm.
range basically what it does is it will say again, similar to slice. Range has three inputs it can take. Okay, you can see here it says stop is compulsory needed, but you can give start, stop, skip. Three things. Again, start, stop, skip. These are the three things you can give as input. Okay. So when I say
Mm-hmm.
start at 0, go until 10 in a step of 1. So what it does is it will create a list called 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay.
Mm-hmm.
So it will do exactly this, but it will not write it this way. Right now, if I am writing it this way, what happens is it will create. So imagine if I give, let's say, like this 10 million. So it will have to create such a big memory space and just store that numbers there, which it doesn't need
Mm-hmm.
to. So there is a concept called as iterator, which you have seen in that. Okay. So it will
Mm-hmm.
create an iterator. Range will create an iterator actually. Okay. Which don't break your head right now what an iterator is. It will just instead of storing this entire list as a list, it will store one value at a time. That's all. It will not store this entire list.
Mm,
Okay, that is what iterator does. But basically, it
mm,
functions like a list only, exactly like a list or a tuple or anything. Any of them can be used and made as an iterator.
mm,
Okay, so okay, maybe list. Very simply, I'll just show you what an iterator does. For example, here this is my list. Okay, so if I go
mm,
write my list, it shows apple, banana, cherry, orange, mango, carrot, radish, potato, burger, pizza. Okay. So if you
mm,
see the size it will take all of this and store it in memory. What iterator will do is, so the way to create an iterator out of this is iter on my list, for example. This is how you'll write. So this is my iterator. Okay. So now what you'll say is when you call my iterator, it will say this is a list iterator. It's an iterator of type list. So for calling the first value of my iterator, you have to say, get me the next value of my iterator. It will give you the first value, apple, which is here. When you say next again, it will give banana. When you say next again, it will give you cherry. When you say next again, it will give you orange. When you say next again, it will give you mango. You can say next until you reach the end of the line. Okay, until you go up to pizza. Okay, burger, pizza. Now it is at the end. Now if you say next, it will say stop iteration. So basically, iterator, as of now, you don't need to understand why, how, and what it is. It is a memory efficient way of writing a iterator. It's a memory efficient way of writing something that you have to run in loops over. Okay, so
So iterator, do you know we only use in this like list? Do we use that in also in string like this?
string and tuple are tuple you can make as an iterator. String I have never done as an iterator. Maybe you can do. I don't know. Even let's try it out. I don't think you can. Let's try. My iterator is equals to iter of my string. Yeah, you are able to. So next of my iterator, it is giving you see first word. Then if you do next, it will give you h. Then if you do again, it will give you e. So it is working, but there is no practical use case of doing it on a string. Okay, doing it on lists
Mm-hmm.
and tuples, you will do it. Especially if you are writing your own custom iterator, then you will do it. Use iterators to save space, especially. So imagine if you are doing something like a Fibonacci series. You remember Fibonacci series? Zero, one
Mm,
are the first two elements. Then add zero and one, you will get one. Add the last two elements, 1 and 1, you will get 2. Then add last two elements, 1 and 2, you will get 3. Then add last two
three,
elements, you will get 5.
5,
Then you will add last two, you will get 8. Then add last two, you will get 5 and 8. If you add, you will get
13,
uh, 11.
12, 12.
Sorry, 13, correct. 13. Then if you add, you will get 21. Okay.
Mm,
This series is called as Fibonacci series. So for things like this, you can use iterators to make it efficient. But why, how, and all that we can look at it later. Uh, so range actually creates an iterator. So if I say range of 0 to 10, okay, it will create a iterator. So if I do type of range of 0 to 10, okay, it's type of range. So range is kind of an iterator. Exactly what it does is kind of iterator, but uh, what I can do is I can make it into show it as a list to you just to show what it is x for x in. So if I write, it says start from 0, go until 10 in steps of 1.
mm-hmm.
Okay. So I can change this 1 to 2. It will make it 0, 2, 4, 6, 8. I can change this to
Like how
3.
you're using this X for X in range, right?
This is called as list comprehension. What I am writing here is called as list comprehension. So I
So we
don't
didn't
want
go
to,
to that class right now, no?
we didn't touch that topic. If you want, you can
Mm-hmm.
go to right now. I would prefer you not to touch that right now. It will
No,
confuse you
for after we'll
further.
go step by
Okay.
step. Yeah.
I mean, it's a simpler way of writing. So list compression offers a shorter syntax when you want to create a new list based on values of an existing list. That's all. So this is how, for example, here is a list called fruits, which has five elements in it. There is a new list called
Mm-hmm.
nothing with no element. So for each element in
Mm-hmm.
fruits, so for x in fruits, so x means each element. You can read it as for each element in fruits. If a in x, so if the word contains the letter a, okay, then
Mm-hmm.
store it in new list. So what it'll do is it'll search, does the first element, so for x in fruits, when it runs first time, x is equals to apple. So does it have a?
Mm-hmm.
Yes. So it'll store it in new list. Does banana has a? Yes. So it'll store it in new list. Cherry has a? No. Kiwi has a? No. Mango has a? Yes. So it'll store apple, banana, and mango in new list. Okay.
Mm-hmm.
This is how you'll write. Okay. Let me just run this code for you. Just because you have asked, I'm telling this.
Mm-hmm.
Okay. So if you do this and if you run your new list, okay.
But it's kind of confusing then.
Okay. So what happens is, so when you say for x in any data structure, okay, like
Mm-hmm.
one which has positions, like list, tuple, string, any of them, if you tell exactly what it will do is it will take the first value when it runs first time. So for is a loop. So loop means it will run some number of
Mm-hmm.
times, more than once. It will keep running until it starts from here and until it reaches here, it will keep running. So first
Mm-hmm.
time when it runs, the value of x is a.
Mm-hmm.
So imagine in C, it's a better way we write. So C in C, the for loop is written for I is equals to 0. Okay. I less than or equals to 10. Okay. I plus plus you write. In C, this is how you write a for loop. So what it means is
Mm-hmm.
start at 0, go until you are less than or equal to 10, and for every iteration add once. Okay.
Mm-hmm.
So what it'll do is it'll take first I as 0 in first loop. Okay. Then it'll
Mm-hmm.
add 1 at the end of the loop. So I becomes 1. So at that time it'll check if
Yeah.
this condition is true or not. It is true. So it'll run again. Then it'll add 1 to
Mm-hmm.
this one. So it'll become 2. It'll check this condition. It'll keep doing that until
Until
it
it gets 10.
reaches 10. Okay. Okay. Once it reaches 10, what it'll do? It'll run this I plus plus. It'll become 11. Then it'll check if this condition is true or false. It is false. So it'll exit out of this loop. So it'll go outside the loop and run the next lines of code.
Mm-hmm.
Okay. So similarly, if you write
Okay.
for x in a list of elements A, B, C, D. Okay. So what actually, if you have to write in numeric terms, what you are doing is for x in range of length of this A, B, C, D. Okay. Length of A, B, C, D is 4. So range of 4 is you are taking 0, 1, 2, 3. Okay.
Mm-hmm.
So, and you are saying x
Mm-hmm.
is the value at position 0 first. So it is A. Then it is the value at position 1. So it is B. So next it is the value at position 2. It is C. Next it is the value at position 3. It is D. Once it is out of here, there is no position 4. So it will come out of the for loop.
Mm-hmm.
Okay. So you can just to understand how a for loop works, you can just do this for something in, let me take an example of Star Wars. Okay. Avengers. What else? Some nice movies. Titanic.
Mm-hmm.
What else? Triple R.
Transformers. Mm-hmm.
Yeah. Transformer. Okay. Okay. And inside this, run a print statement saying, okay, this what I'm writing is called as an F string. So you don't. again worry about it. Tomorrow we'll discuss F strings, R strings, B strings, and all those good stuff
Mm.
tomorrow. So uh, currently the of value of something is something. Okay. What I'm saying is, when you run this loop, how many times ever you run this loop, what is the value that is stored in something? Print that value. Okay. When I run this, it says first time the value is Star Wars, second time it is Avengers, third time it is Titanic, fourth time it is Range, fifth time it is Transformer.
Mm.
Okay.
Mhm.
Similarly, instead of this, if I write range of 10, okay, it will say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I say range of
Mhm.
2 comma 10, it will say 2, 3, 4, 5, 6, 7, 8, 9. Starts at 2, ends at 10, ends before 10.
10.
Okay. 2 comma 10
Mhm.
comma, let's say 5. And it will say 2, then 5,
2
it
and
will jump,
7.
then it will jump 5 again and it will see if it is greater, then it will stop.
Stop.
So range basically does similar to your slicing. It has start, stop,
Mhm.
step. This is called a start.
Okay.
Start at, stop before, step how
And
many?
jump.
Jump or
Mm.
step. Like you're
Mhm.
climbing stairs, one step or two step or three step
Yeah.
you'll climb, right? Like that.
Okay.
Okay, so that explains range hopefully for you.
Yeah.
Okay, so now coming back to list comprehension. So this one now you will be able to understand this code easily, right? So what you are doing is for X in fruits. So first time it is apple,
Apple. Yeah.
okay? And in apple, do you have the letter A?
Mm.
So here
Yes.
A in X means does the value A appear in X? X is apple here.
Mhm.
So does is there in X? Yes. So this is true.
Yes.
Since this is true, this line will run. Okay.
Mhm.
So new list will be added with apple. Then second time it is banana.
Okay.
Does banana have A? Yes.
Okay.
So
So we need to give you the new list also, right? New list is equals to.
it will give you output new list. So after you run it and then you see it will give you apple, banana and mango because all of three of them have the letter A within them.
Mhm.
But cherry and
No,
kiwi does
if we
not have.
don't write this one, I'm saying if we
Which
don't
one?
write new list is equals to square bracket, empty square brackets.
So when you say new list dot append, if I don't write this line, what it will say is where should I append? I don't know where should I append. It is not defined beforehand.
Okay.
Either you can define it like this or you can define it like this. Both are same. What I have written this one, or if I write new list like this, both mean the same thing. Here you are saying new
Mhm.
list is an empty list. Here I am saying new list is an empty list. Same
Mhm.
thing, different way of writing. Okay.
Okay.
So
Mhm.
this is a simple way of writing it, the clear way of writing it. For list
Mhm.
comprehension, what I can do is I can write x for x in fruits if a in x. So this does exactly what this entire thing does. So
Mhm.
these four lines of code is written here. Okay. If I
Mhm.
write like this, exactly what you write in these four lines is written in one line here. This that is why it is called as list comprehension. You are writing a simpler way of doing this.
Mhm.
That is why you don't need to know this right now because there is a
Yeah, that.
clearer way of doing this exact thing.
Mm.
Okay. Just if you want, you can just like new list two. Okay. And new list. So for example, if I run this and say what is new list, it will give you that. If I run this and write new list 2, it will give you that. So new list, the value is apple, banana, mango. New list 2, the value is apple, banana, mango. So it does exactly what is done here, but instead of writing four lines, you're writing one line.
Mhm.
So list comprehension is this thing. You don't need to
Okay.
know this, okay? It's once you become a good programmer, not basic programmer, then you will use those kinds of things to ease your effort. Because first
Yeah.
time when I did this thing, it confuses the hell out of me. I
Yeah,
don't understand
even.
what is happening. Okay. As I
Mm.
kept doing it, I was